Welcome to DOE analysis. I'm going to show you not only how to analyze one, but some pitfalls that you're likely to run into and how to overcome them, and why you'd want to start with a very small DOE if it's your first in a sequence of experiments. So here we go. What you're looking at on screen right now is the winning combination of treatments that I did in a DOE I planned about a month ago. You can see that all elsewhere on the channel. This is spinach growing in a solo cup, and it's treatment number 4 from the DOE. This was the plan I did, and here's a simplified version of the table. I'll show you the full thing later. But for now, just know that it was a 4 treatment DOE. Each row in here is a different seedling that I grew in a different scenario. Here are the 3 factors. It's a very small DOE. I plan it this way just because it's the first experiment I was doing in this space. Don't have a ton of expertise, didn't know exactly what level settings to choose, but I was curious about all the rumors I hear about planting in seed trays is better than planting in solo cups, larger cups to germinate seeds inside. Amount of water, every day versus every other day, I kind of just picked that on a whim. I thought about doing a tablespoon versus a cup of water, but I just went every other day for half of them, every day for the other half. And then what I really wanted to know was actually, I've been growing these under a fluorescent lamp, allegedly meant for growing seedlings in a spare room. Like every spring, I do that. But I wondered, since this is a smaller experiment, I don't have quite as many to grow as I do in the start of spring. It's summer right now when I'm filming this. What would it do if I put it at the windowsill? And if you just look at some of the notes here, just the appearance after a couple of weeks or the final results notes, like something about this treatment was amazing, and something about all the rest of them was not. Okay. But the metrics I thought that I would collect, my original plan was just to look at the height. And I thought at the time of planning this, the height of that spinach, right? The height from the ground to the top of the leaf, the height there, that picture, 59 millimeters. I thought the height would correlate very well to health of plant. Hmm, And here's lesson number 1. A lot of times when you start your first DOE trying to understand a new problem, and if you're not the expert yet, but it's a problem, so you're probably don't have a tremendous amount of expertise yet, or else the problem wouldn't be such a big deal. So in your first one, you might not even pick the right Y. And if you do a DOE and you collect the wrong Y, just so you know, no amount of statistics, no amount of analysis will reveal the truth or the best direction that you should go in next. So that's why copious note taking matters. That's why you see my sheet here all scratched up with words, not just numbers. And this is super common in the first experiment in a sequence. You should always plan to do, if you're starting from scratch, you should always plan at least 2, maybe 3, maybe more DOEs, because very rarely will you get the answer you need out of the first one. And that surely happened here. I didn't plan for it to happen this way, but it's perfect that it did. I planned this DOE very quickly just so I could get some DOE information to some of my friends here looking at the channel. And planning it so quickly, especially, I think, especially factor B, the amount of water I use or the frequency of watering, I think that was a little too dramatic a factor. I think that caused havoc on growing these seeds. And that happens in real life too. I remember working on washing machines when I was at my previous company, trying to do experiments to sense the type of garments or the amount of garments that a user put in, so you could adjust the water level or the temperatures or whatever. Like wanted the machine to be smart, save some energy. Like there were so many surprises there, so many things you could measure, so many things you could control. A sequence of DOEs would let you investigate that. I'm just trying to give you a warning. Don't expect it to be perfect the first DOE. And because of that, that's why I suggest sometimes, like I did here, starting out with a really small experiment just to see if you can even collect the data, just to see if these seeds would even grow in my case, just to see in your work, can you even build that prototype? Would the combination even fit together? And so on. All right. Okay, let's take a look at some results here, and then I'll show you like how the DOE analysis works in Minitab, but I'll also show you how like you could think about this just practically looking at the data and how you could think about the size of effects of these factors. I'll show you some different ways you could do the math yourself. All right, so what do we see here? Just practically speaking, if I were to sort this data, sort the entire worksheet, largest to smallest, sort it by Y of interest. Maybe I'll look at the week 4 height here, sort it by Y. You can start to see patterns like anything that looks consistent up at the top is probably important. This is a very short data set. There's only 4 rows here, but the everydays both come before the every other days. And it looks like that's leading to very much more plant growth. If you want to think about like on average, what is every day in terms of plant height versus every other day, Minitab will do that automatically for you. But if you want to just look at it with me real quick, I could bring up Minitab's graph builder. I could go over, since I know I want to do tabulated statistics, I could go over here and I could say, please Minitab, summarize the average, the mean of plant height according to my factors. The one of interest here, maybe I'll do it this way. Oh yeah, that looks good. So every day, average height 68. Every other day, average height 17. So if we were to graph that, like factor B, from the minus level to the plus level, or in this case, every other day versus every day, if we look at that, then we go from 17 to 68. Now, I did not predict it would be that dramatic. My prediction would have been probably much more like this. So this is a different result than my prediction. That is evidence of learning something. So that's good. We learned something. In fact, if I were to make predictions like this for all the factors, I would have said they all should have some kind of trend like this. Like for factor A here, when I was studying solo cup versus seed tray, what the internet was trying to tell me was for factor A here, as I go from solo cup to seed tray, was that we should also have better results, at least healthier plants out of the tray than the bigger solo cups. And I really didn't know what to expect for this. I kind of thought it'd be very similar. Like if I were to have done the prediction for C, which I did in my head, I didn't write it down. That's why I'm redrawing it for you here. Uh, if I did fluorescent versus window, I would have expected that to be almost flat because I've been growing these under fluorescent light every spring for a while now, a few years. Not long. I'm kind of new to gardening, but it sure seems like they do okay under the fluorescent light. But now, as I mentioned in the intro, it sure seems like this assumption was dead wrong. Maybe for height, okay, maybe for height that is somewhat true, but for the plant's health, the window seemed dramatically better. All right, so we could do the same thing if you wanted to see that for lighting, 43 versus 42, almost flat in terms of the height after 4 weeks of growing. So I kind of matched my prediction, but all I'm saying is like I had the wrong Y altogether. Even though these match, the windows still, those plants looked much, much better than the fluorescent. All right. And what was the other one? Container. Big difference, but in the opposite direction. No, it's the same direction. Seed tray was allegedly supposed to be higher than solo cup. All right. So maybe there is something to that after all. All right. If you, instead of doing it the hard way, like doing the math, averaging these, I mean, that's all DOE is. Take the averages, of the plus levels, subtract off the minus levels. That's the effect. Um, you can get an equation for that if you go to the DOE menu. Like factorial design is what I did to create this. You can check the other video from earlier to see more about that. But we'll go to analyze. You could say analyze, we could analyze all these if we wanted to at the same time, but I'm just going to analyze Y4 here to keep it simple for the audience. You can check your terms. Like here, I'm going to calculate the main effects. For those of you advanced in DOEs, you'll question, why aren't you adding any interactions in there? Or at least you'll look at the aliasing structure here and you'll see when I see factor A, that's actually aliased or confounded with the BC interaction. So there's some risks in doing this. Like I'm not sure if when I calculate this, the effect of A, the container, from seed tray to solo cup, when I calculate that, I don't really know if that's the true effect of the container or if it's partly the effect of the B by C interaction, which is the interaction between water and lighting. So it's risky to trust any of the quantitative things here. However, I think you're going to like some graphs that come up. And I'll show you just in general the DOE output so you know how to interpret it. All right. So we've got the three factors here, their effects, 16, 50, 1. Remember I said that one was a huge one. It just did the averages, subtracted them. It said 50.5 is the difference between every day and every other day watering in terms of Y4 plant height. Okay. Here's an equation. DOE gives you an equation. It says Y4, that plant height at week 4, is about 42 millimeters. But you have to subtract off 8 if you go to the worst container, or if you go the other direction, you get to add 8 millimeters. Regarding H2O, if you go with the everyday, you get to add 25 millimeters. Every other day, subtract it. And lighting, very little difference between the two. Look at the size of that. I mean, from plus to minus the 0.75 versus the 25 millimeter differences. Now this chart shows those graphically, like these effects that I just called out above, they're graphed here on this direction. They're also charted against a line that represents where you should believe that a factor's effect is true, is significant. And none of these go up past that. So it's like the noise in this experiment is so great that I don't know if you want to trust that. Or it could be because this is just a 4-run DOE. It's hard to trust that. This line is maybe a little better if we had more data points here. You'd have more statistical power. Or length PSE if you're into this, the DOE metrics here, length PSE, which is what I'm using here in this unreplicated analysis. Kind of struggles when you have few data points. It's based on sparse effects that are significant. If you only got 3 effects up there, it's hard to see which ones are the important ones and which ones are not. All right. So now that we fit the DOE, you got access to a few other graphs. Right back to factorial, right where we created it, right where we did that analysis. Notice these are now no longer grayed out. We could make a prediction, like we could say, I want these combination of factors. How tall would my plant be after 4 weeks? That's what predict does. Or we could run the response optimizer. We could say, I want a plant height of 75 millimeters. What do I have to do to get there? And it would tell you the level settings you need of A, B, and C. But before you do that, I think a good place to start is the factorial plots. It's the graphical version of exactly what I was showing you with my hand sketches earlier. This is what you should compare against your predictions before the DOE. If you wrote the predictions down, it's like super easy. This is the exact same graph, right? It's like here, the y-axis is plant height. And we've got factor A at the minus and the plus level, factor B at the minus and the plus level, factor C at the minus and the plus level. and you get to see graphically the relative effect. Like, holy moly, the slope of B is so much steeper, much more important than lighting for week 4 plant height. Although keep in mind, remember my intro, like this measurement was only part of the story at best. Like visually, the ones on the window looked so much better. Like the ones under the fluorescent lamp, honestly, just like my spring plants. So it wasn't too far off. But just like my spring plants, they're real long and spindly. Like here, say this is the planter. This is what a plant would look like under the fluorescent lamp. And this is what it would look like on the window. And actually there were several more leaves on the window. So I mean, you be the judge. Is why that I was considering the most important, the height, is that really indicative of plant health? Or should I just look at my copious notes in this case and plan another study to try to make it healthier? I don't know. But what I do know is in this case, I did not budget for enough time, money, resources, lab space, etc. before the production start date. Production date is here. I have to put this spinach in the ground, so I'm just picking all the ones that look good and I'm putting them out in the garden. Okay. Uh, in real life, that would be a shame if I only had time for this tiny little DOE. In real life, if this was for work, for sure I would have done this earlier and been ready to do a follow up DOE as soon as this was done, because I would know at work, this is important. I have to hit a production date. I'm going to want to do a follow up study to really optimize rather than this really quick intro, this resolution 3 4-run experiment, just to get started and see if I can even plant these and grow these seeds. All right. Some other interesting things here. I mean, this DOE was quite different from my spring growing. Some people would call that the unit structure. Like the unit structure, the things that are constant between my spring growing, during my growing. It's like I always use very good soil. Um, I always plant them, water them the same way, very consistently. The soil's always moist. I actually have a moisture meter that I use. I probably could have used that here. But then the unit structure, all the things that stay the same within an experiment. In this experiment, I used just cheap, dried out dirt that I had started in the spring but didn't need anymore. So I just reused some dirt. So that alone, like this entire experiment, all these data points came from a very different soil source than I'm used to using. So all these results, because of that, I run the risk of them not applying when I go to the spring and I use good soil again. So writing down the unit structure, like drawing a tree that shows your experiment. Maybe I'll show it like this. Unit, I'll draw it in red. Red, please. Unit structure. All right, I have dry old soil. If you just write this at the top of your DOE, then people will know, this is different than spring. This is different than the production cycle. This is different than how the lab does it. Dry old soil, clear solo cups, standard trays. I did use the same exact trays I use every spring. Okay, and then we can switch over to black or blue and we'll draw the rest of the experiment. So we had factor A, B, C, right? Out of this unit structure, we would split. I would try to do A at the plus and minus, B at the plus and minus. And what was my aliasing here? C, remember I only had 4 treatments, 1, 2, 3, 4. And I said C equals A times B. So this would be plus, minus, minus, plus. Now, if I was really doing a good job, I would even go in here and I would say, like, what are some of the details about A, B, and C? Like there really was, like, maybe you could argue there was a line of restriction here, because when I did lighting, factor C, this was in a totally different room, room 2, room 2, than these two. These two were in room 1. You could write that down on your chart. If you have a tree like this, whenever somebody goes to look at your data, they understand exactly what you did for your experiment. So that's a good tip too. Write that down, document it in your notes. Don't just rely on the numerical analysis. Rely also on your copious notes, your subject matter expertise. And that is a good start for you getting used to DOEs in general, DOEs in Minitab, Graph Builder in Minitab. Hope you enjoyed it. All right, see you next time.